on behalf of the Department of Mechanical Engineering, and Dr. Muthukumar going to initiate the session 9 today. We have Dr. Loganathan PG, is Associate Professor in Guru Tulsidas Vishwavidyalaya. To have an introduction of him, I kindly invite Dr. Sankaralingam sir to introduce him elaborately. Sankaralingam sir.
Come to all dignitaries, faculty members, researchers, on the technology process.
One second. Sir, kindly hold on.
Sir, good morning, sir. Sir, am I audible? Sir, Muthukumar sir, shall we start?
Kindly wait for a second, sir. We'll introduce you.
Good morning to all. On behalf of WellTech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College, Avadi, it is my proud privilege to extend a warm welcome to all the dignitaries, faculty members, researchers, and the participants who have joined us for 6-day faculty development program on emerging materials and advanced technology for sustainability. I am Dr. Sankaralingam, Assistant Professor, Department of Mechanical Engineering, and it gives me a great pleasure to welcome you all to this academic gathering, organized with the objective of enriching knowledge, strengthening research perspectives, and fostering academic excellence. It gives me immense pleasure and a great sense of honor to introduce our resource persons for today's session, Dr. T.G. Loganathan, who will be presenting on the topic research scope in green and biodegradable composite. Dr. T.G. Loganathan is distinguished academician and accomplished material researcher, currently serving as Associate Professor in the Department of Mechanical Engineering at Guru Tulsidas Vishwavidyalaya, Central University, Bislapur, Chhattisgarh. He holds a PhD from Anna University and has over 26 years of rich teaching, research, and academic experience. His area of expertise includes composite material, strategy and good studies, non-destructive testing, additive manufacturing, advanced manufacturing, and new product development, supported by strong proficiency in statistical tools such as SPSS. He has also completed postdoctoral research at University of Wolverhampton, United Kingdom, where he contributed to European-funded research projects in the area of advanced composite and manufacturing technologies. He has an immersive research profile with more than 40 research publications, including 29 papers indexed in Web of Science. He has contributed multiple book chapters published by Elsevier. In addition, Sir holds 4 granted Indian patents, along with several published and filled patents, reflecting his strong commitment to innovation, applied research, and technology transfer. Currently, Sir research focused on advanced and sustainable composite material, functional material, additive manufacturing, and high-performance engineering system aimed at next-generation industrial applications. We are extremely fortunate to have such an eminent researchers and academician with us today. I hope that today's session is sure to provide a deep technical insights, research perspectives, and valuable guidance to all participants. On behalf of Welltech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College, I warmly welcome Dr. T.J. Lognathan sir and take him for gracious accepting our invitation and sparing his valuable time to be with us today. Welcome, sir.
Hello, sir.
Thank you very much.
Muthukumar here, sir. Is the introduction okay, sir? Has anything uncovered about you?
No, sir. He has given.
If I could stop the presentation, sir, you can present your slides. Stop presenting. I am stopping presenting. You can start presenting your slides, sir.
Yeah, thank you very much for your warm welcome and this opportunity. And I should be grateful to Professor Muthukumar sir for inviting me to this FDP session. And just I'm going to share my small experience with the learned members of this forum. And basically, I am working on composite material. And as of now, today, the scenario is totally towards sustainability. So that is the order of the day. So keeping that in mind, I have collected some of the work which I did along with the global scenario. That may be an input for our learned members. And for some of them, it may be an input to take the research forward as well. So keeping that in mind, let me go into the presentation. Sir, is my screen visible, sir?
Yes, sir. Yes, sir. It's visible.
So, perfect. As the FDP is on emerging materials and advanced technologies for sustainability, so my topic is going to match well with the present title as well. So it is going to be on research scopes in green and biodegradable composites. And the presentation content comprises of a small introduction about green and biodegradable composite, how and all they are classified, what is their international view, how it is taken care in a global scenario, and what are the various ways to characterize and testing, what are the methods and approaches people are following, how we can implement that, and the current research scopes and challenges, and then conclusion. So this is how it has been going to be presented today. So as you all know, composite, it is very old concept actually. It was started in the year 1975. It's almost around 50 years old concept, but still people are using a lot of innovation in that. So the recent innovation, it is going to be on green and biodegradable composites. So this is the area where people are much focused today. Though the scenario started with the ceramic composite, metal matrix composites, which are all for a high durability and long-lasting services, especially in high-temperature applications. Later, they came into synthetic fibers with the polymer matrix. So that is the second category. And now at present, people are working on natural fibers and reinforced composite. So this is also not new. As we are seeing, it is near about 15 years old. But the scenario now, it is going to be totally on bio-based biodegradable composite. So this is the order of the day, where people want to have everything going to be safe to the society and the environment. And before going into that, first of all, we should know what is biodegradable. So biodegradable is different from bio-based. So whatever we are taking from nature, it is not, or whatever we are telling it is bio-based, it is not biodegradable. So bio-based are the plastics, which are all from the biological resources. Even it can be from other material, but it need not be compostable, that it never gel up with the environment. So that is the problem with some of the bio-based, but biodegradable is the one which can be completely integrated into the atmosphere and which can be transformed into water, carbon dioxide, and it can get composed. But what is the advantage of this bio-based? So this we can focus on recycling. So that is also another concept where circular economy principle has been deployed here. So whenever you are having bio-based extracts, So if it is not biodegradable, we should have the opportunity for recycling it. So with this idea only, we should work on the material, and that is how people started working on this. So what do you mean by green and biodegradable composite? So biocomposite, it can be a polymeric matrix and reinforcing fibers, which is the prominent ingredient of the composite. People are very well understand this because most of the people are working on composite. So these are all the two major ingredients. One is the matrix, another is the reinforcement fibers. If any of them or both of them are bio or agro origin, then we call it as a biocomposite. So there is no question of whether it is a biodegradable. When it is coming under the category of biodegradable, it is going to support the sustainability concept, that it never disturb the environment or the society. So in such case, we should have a very clear classification with respect to biocomposite and biodegradable. And the concept of green is quite common now. So green is a polymeric matrix from biomass or petro-based resources, and that is biocomposite is biodegradable. So when it is called as green, it is going to be completely nature-based. So it is going to support nature. And the last terminology is the sustainable composite. So sustainable biocomposite, the overall impact of the composite is not going to be dangerous to the environment. So it is going to safeguard. So we are always thinking about the present, but at the same time, as a researcher, we should think about the future also, how and to what extent we are going to protect our environment, or we are going to safeguard the environment. In the other way around, we should not damage the environment. And going back to the classification, so this classification will help us to understand what all the various resources by which we can able to get the matrix. So in a nutshell, we can see that this small picture which I have taken from one of the research article. So we can have the matrix both from biologically derived or from fossil fuel. But here there are 4 quadrants. In that, the rightmost, the top quadrant is going to be have bioplastics, which is biodegradable, like a PLA, PHA, PBS, and starch blends. There are some of the biological derived, like a bio-based polyethylene, polytetraethylene, PA, PPT. These are all, though they are derived from the biological resources, but they are not biodegradable. So it means that we need to recycle it. So this is a challenge what we have. So some of the fossil fuel based, that is PBAT, PCL, this is also bioplastic, but that is biodegradable. So this classification, once you know, then you are going to be on the forefront of the sustainable concept. And here we have a very large list of bio-based biodegradable plastics, like a thermoplastic starch, which is derived from starch, like a corn starch. We can take that and we can synthesis and we can take the plastic out of it. Cellulose acetate, polyhydroxy alkonates. So these are all some of the things which are all produced from nature, and it is biodegradable. So it means that you can forget about the end life problem. So you can throw it off in the environment, nothing will happen. And another synthetic plastics are PLA, polybutylene succinate. So these two are produced by synthetic process, but this is also environmental friendly. Apart from that, these list bio-based, non-biodegradable is also available. So when you are using that, we always think about how it is going to be this lifetime. It should not be thrown into the atmosphere, so it should be recycled. So from this we can able to classify on which polymer we are going to work. If we are going to work on the first 5 category, then it is going to be environmental friendly, right? On the next 7, it is going to have an impact on the environment. So we should be very careful that, this 5. We should be very careful that we should be in a position to recycle it. And some of the bio-based resin which is commercially available in the market, which you can try on. So these are all meant for deploying in some structural applications as well. So that is coming up in the market. What is triglyceride acrylate, which is called as Tribest. So the commercial name is Tribest, which we can procure and we can try it, because most of the things are all slowly coming up. The problem is the cost factor. And epoxide pine oil based, This is also one of the bio-based resin. Unsaturated polyester resin from renewable and recycled resources. So these are all the some of the brand names: Tribest, Epobeox, Ashland Endurance, and Polylite. So these are all some of the commercial people. Those are using bio-based resin, which we can procure and we can use it for our research and analysis. And going back to the utility, so for that we have to see how internationally this bioplastic is going to play a very vital role. So this is as per the European Union record, which is taken recently. So the total consumption of this bio-based plastics is around 0.33 million tons. It's a very huge mass. And in that, you can see the classification: bio-based biodegradable and bio-based non-biodegradable. But basically, it's all bio-based plastics. So it's where around 0.33 million tons. And the projected consumption, so by where around 2030, it is going to be 0.80 million tons. So around 0.5 million tons is going to be increased. So this can give us a picture that how the utility of biocomposite is going to be enhanced throughout the globe. So bioplastics are used for increasing variety of applications. So these are all the three major areas: packaging and fiber to consumer goods, automotive, and agriculture. So packaging is a very vast field where people are using in Western countries to preserve the food material. They are not using synthetic material. They are using biomaterial. So that is one of the major area. And as I told you, some of the things are all being reinforced with the fibers they are using for automotive and agriculture products. You can see here, packaging remains the largest market segment, which were around 50% of the total bioplastic market. And automotive is coming around 11%, you can say. So this percentage is going to give us a good insight that in future, it is going to increase further. And whenever you are talking about lightweight, reusable material, then we have to go with the bioplastics. And this is the comparison between current and the future. So there is going to be a tremendous rise of bioplastics overall. Globally, it is going to be around 100 times it is going to increase. So you can see here, there's a large increase in the food industry, like packaging. And next comes the fiber, consumer goods, automotive, transport, agriculture. Even electronics also, they are going to use bio-based plastics. So if at all you are planning out your research on the resin extraction, if at all you are in a position to extract some resin, you can do some sort of chemical analysis, durability studies, and other in collaboration with the chemistry department, and you can even file a patent on this particular domain. So that is the advantage what we have when you are working on some type of newer materials. And coming back to the utilization rate, in the last year, the bioplastics utilization was around 63%, right? Out of the production, it was used 60%, and around 37% it has been unused. Whereas in the current year, there is a proportionate rise of production and utility. Around 72% has been used of the total production, and 28 is going to be 28 is the unused. So you can see that the production is increasing as well as the utility is also increasing. So eventually there will be a high scope in future as well. And so far we discussed about the one of the major ingredient that is a matrix. So biopolymer. So how biopolymer are going to play over the global scenario as well as the Western countries. But now, along with that matrix, we need one of the strengthening agent, that is the reinforcement. So here, this is going to give you a clear picture how the natural fibers are slowly coming up into the market. So we were seeing starting from 2020, there is a gradual rise in the utility of this fibers. So starting from wood fiber, flax, hemp, kenaf, cotton, and others. So others which all inclusive of sisal, pineapple, which are all going to be which are going to be cultivated in a less quantity. That's why it's all kept under one category. So, but this flax, hemp, and all, it is all having a very large volume of production. So you can see that it is gradually increasing, and it is having a very huge market. So this is also another input we can able to assure that the use of natural fiber is also going to be quite encouraging. So this is the data which is taken from the market research report from the global headquarters. So the total value of the natural fiber composite somewhere around 9.4 billion USD. So it's a very huge market. And coming back to the utility of this natural fiber, we should be very careful what all the drawbacks involved in it. So now the major drawback is comparing with the synthetic fiber, it is having some one of the major drawback is the moisture sensitivity. It is mentioned here. So this is prone to get degraded when it is exposed to moisture. So in that way, we should be very careful how we can prevent or how we can treat the fibers in order to have a durability when it is exposed to atmosphere. So these are all some of the challenges still we have. So those challenges we have to transform as an opportunity for doing good quality research. And in the present slide, we can see what are all the various types of fibers. Some of them are using most of the fibers. Other than that, there are a few more fibers are there. So only thing is you should know what all the resources we are coming across. So one is from the main part of the tree, that is the wood. The other one is from the stem, leaf, seed or fruit, other from the grass. Under each category, say if you are taking leaf, there are different varieties of fiber like sisal, abaca, pineapple, banana, ficus, palm. So if you come across any long leaf, we should be in a position to explore whether that is having any fiber inside. So if you are capable of extracting those fibers, then that will be a new fiber which you can bring it to the research community, and you can motivate the people to work on that particular fiber. Thereby, indirectly, we are supporting agriculture also. So these are all some of the basic classification. Like you can take fibers from wood. Even recently, people started working on the shells of fruit, wherein they may not get a continuous fiber. They will be getting some sort of powders that can be used as a filler in order to arrest the damage progression in case of continuous fiber reinforced laminates. So these are all the classification where people able to understand how and where and all they can have some opportunities to explore. So coming back to the potentials of the natural fiber. So here you can see we have some classification of natural fibers, followed by some of the most commonly used synthetic fibers like a glass fiber, carbon fiber, and Kevlar fiber. So first of all, we should understand in what way these natural fibers are most preferred. The reason is they are light in weight. So the density itself is going to be the proof of that. See, some of the fibers are all very, very light when compared with the glass. And then going to the Young's modulus, that is the stiffness parameter of that. Natural fiber is not very weak actually. So it is somewhere equivalent to glass fiber. Somewhere around, say, flax fiber, if you take, it is around 72, but it is equal to glass fiber, which is having around 70. And elongation to failure, that is the strain, which is very good. So it can able to undergo a lot of deformation. So this sort of picture is going to tell us that though we cannot replace the synthetic fiber to a major extent, but wherever possible, the synthetic fibers can be downplayed by these types of natural fibers. And on the right hand side of that, you are having some of the tests which you can able to do to measure the strength of the fibers. And characterization of natural fiber. So what are the properties of the natural fiber which you have listed earlier? It is based on the ingredient of it. So those ingredients are very much essential in order to identify what is going to be the strength of it. So here you can see a list of natural fibers, and they are classified based on their percentage of cellulose, lignin, hemicellulose, pectin, and ash. So these are all the major ingredients which is present. Based on the proportion of this ingredient, the property will vary. So a large a percentage of cellulose will have its own benefit when compared with the one which is having a less percentage of cellulose. So these are all the basic ingredient which is not in our control. It is based on the type of the plant. So whenever you are identifying a plant, first our job is to find out this composition analysis of the fiber. Once you know this, based on that we can able to map the property with the other fibers. So for example, if it is going to have an hydroxylic group that is in cellulose, that gives the natural fiber water attracting nature. So hydrophilic properties, which is going to be somewhat it is able to easy to absorb the water. So once it is having that property, then it may undergo some degradation. So that is going to be very important. So that results in poor interface and poor resistance to moisture absorption. So when you are having this high percentage of cellulose, though there is going to be a strength component, it will attract water. So we need to go for some surface treatment that we'll see in the forthcoming presentations. So when you are having natural fiber, as I mentioned, it is having some of the properties. Those properties may not be appreciable for structural application. Then we have to go for some chemical treatments. So these chemical treatments include alkaline treatments. So either you can use NaOH or NaOH like sodium hydroxide, potassium hydroxide. You can able to treat that. Acetalization, you're using acetic acid. Using benzoic acid, you can use some sort of treatment. And we did this treatment, sealant treatment. Sealant treatment is quite oftenly conducted, and we also did this on some of the natural fibers like sisal. We encountered a better strength because of the good bonding between the fiber and the matrix. So this is one of the proof which we ourselves experienced. Other than that, you can try about all this. So the basic objective of all this treatment is to tell you that how and all is going to enhance the property of the material. Like if you are going with alkaline treatment, it increased surface roughness, results in better interlocking with the matrix. Based on this, you can ensure higher tensile strength, varying from 0.13 megapascal to 0.9, around it can be around 0.2 megapascal. So this sort of improvement is the research gap. So most of us, we don't know how to enhance our research. So some sort of treatment will help us to identify how and in what aspects the fibers are performing better. And similarly, when you are using acetic acid on the banana fiber, which is having dimensional stability and decreased hygroscopicity. So by this, the impact strength is increasing. So these are all some of the literature data. So you can able to try some of this treatment in combination, varying concentration, and you can prepare on DOE and you can find out which is going to be the optimum concentration for a specific type of fiber. So these type of research is still lagging, and that will support the industrial person to identify exactly what percentage of concentration will have the maximum or the optimum strength parameter. And here I want to present one of the work which we did in our campus. This plant most of us would have seen in the garden, which is called as fishtail palm conventionally, but biologically it is called as cryotornis. So we were wondering about this fruit stem. It is going to be a very long stem for around say 2 or 3 meter length. So that used to grow as a very long stem bearing a flower, and at the end it is going to have a fruit. Once it is going to reach the ripened state, the fruit after ripening it may fall, and you can see that long strands. So we were wondering whether this is having any fiber inside. Then we started extracting that, and we subjected to some processing of retting, making them soaking in water and then retting, and we extracted some fiber. So this fiber is not invented so far, and we did some of the tests. As I mentioned, we did a chemical composition test, density, and we did XRD, fiber and everything. and by which we got to know that this is going to be very innovative in nature, and we applied for a patenting as well. So luckily we got the patent awarded in the year 2024 for this fiber. So far they have worked on the spadix of this. The spadix in the sense which is going to be on the top cover of the flower. So this is the spadix, and the spadix is going to bloom out like a long stem, and this is going to have some sort of flowers, flower buds, and the flower buds after that it is going to become a fruit, and it is going to get ripened like this. Then you'll get the seed. So this is the life cycle of it. After shedding the seed only, I am talking about the fiber. So at last we are in a position to get the fiber. Those fiber have been woven in the form of a mat, and this we tried to file a patent, and after a few procedure we got this patent awarded. And some of the characterization that we need to do. So whenever you are taking up some of the fibers like this, so we should check technically whether what is the durability of that fiber. So one of the tests what you are seeing is thermal analysis. So in which we can see that what is the durability of the fiber over a temperature. So here you can see that the temperature, as the temperature increases, the fiber is getting degraded. So you can see that the maximum it can able to withstand of around 300 degrees centigrade. So this will tell us to what extent the fiber is going to withstand the heat. And indirectly we are telling that this fiber can be applied for some high temperature application somewhere around say 100 or 200 degrees centigrade. Though we cannot point it out to 300 degrees centigrade. So up to an extent of 100 degrees centigrade it can able to withstand. So these types of analysis are very much essential. And another test what we have performed is the XRD. This XRD will give us the crystallinity index. How far the crystal structure is there inside the fiber. So this is the XRD pattern of this particular cryotornus fruit stem fiber. And here we have listed with some other natural fibers available in the market globally. And this is the crystallinity index and crystalline size. So here you can see that the crystallinity index is much higher than Juncus FUS. So here it is very higher than some of the natural fiber, and we can say that it is on par with sisal fiber. So sisal fiber is already proven, and most of the people are working on it. The fishtail fiber is somewhat closer to the sisal fiber. So we can able to compare some of the properties like this as well. And this is one of the very important tests, that is FTIR. This test we performed in order to find out what all the functional groups available and what is the intensity of the functional group. So here you can see that the intensity of the FTIR shows that cellulose, that is hydroxyl group, is having an intensity up to an extent of 3500 per centimeter. So this peak wave number we can able to compare with other fibers. This will tell us that this is going to be water absorbing in nature. So as we understand this, then we have identified silane. Silane is one of the sizing agent. So that is going to be used as a fiber sizing agent, and we have treated and we have studied the mechanical properties as well. So these types of tests will enable us to identify which sizing agent is suitable for the fiber. So as the hydroxyl group is having a high intensity, so we went for this silane. And this is the chemical composition of that. So you can see here the cellulose OH is 344, around 3500, and this is going to be hemicellulose around 3000, lignin around 1600, and CH band of cellulose is around 1400, and cellulose CO band is around 1000. So what is the advantage of this? So when you are having a hydroxyl group, the fiber which is going to be present having hydroxyl group, because of that it may have a good mechanical strength, is appreciable. So when it is having a hydroxyl group of high intensity, mechanical strength will be good. So what's the drawback of that? It is going to absorb water. So we go for some chemical treatment. And the dimensional stability is good. That is very good. And adhesion or wettability will be very good. And chemical reactivity. So it is going to react chemically as well. So there are plus points. There are some negative points. So we have to keep the negative point addressed by means of some other treatment, make it positive, and hoping that if you address those 2 points positive, then we can use it for making a very good structure. And some of the operations we encountered with the composite by bringing drilling into picture. So here, most of us, we know we do drilling in our normal day-to-day application. In composite, how drilling is going to be influential, because all the structures, whatever we make, it is not going to be used as a plate. It is going to have drilling here and there for assembly. So we made a small initiative in order to study how this drilling is going to affect the strength by doing vibration study. So here you can see that we made a glass fiber and natural fiber composite. And before drilling, the natural frequency is going to be of this order, around 46 hertz. And in natural fiber, it is around 33. And after drilling, surely there is going to be a drop in the stiffness of it that we can measure with the help of the natural frequency. And we tried with a different type of drill. One is the twist drill, which is our normal conventional drill. The other one is the core drill. So core drill is a type of a drill which is going to have a cutting edge only on the circumference of it, not from the center. In our normal drill, the cutting edge will start from the center, and like a flute, it will flow along the length of the drill bit. But here, the core drill is going to have cutting edge only on the circumference of the tool. So we tried with that. Eventually, we observed that the frequency is better because of the induced damage is very less. So these are all some of the observations we made out of using a different type of drill tool. So why I'm telling that is these are all some of the small experiment which we can try with the help of resources whatever we have. And this is another test where the samples are prepared and exposed to different temperatures, whether it is withstanding the temperature. So this effect of high temperature on Kenoff fiber reinforced polypropylene composite. So here you can see that when it is exposed to a higher temperature, there is a substantial drop in the tensile property. So we can suggest that this type of composite may not be exposed to a higher temperature, or it can be subjected to some sort of surface treatment, and then we can change the matrix. So if your application is more about temperature, so we can able to change the matrix, do some surface treatment, and we can able to study the progress of it. So these are all some of the insights how we can take up our research with the available resources. And as I was mentioning, one of the resources for the natural fiber, which is going to be a filler type of resource. So this is one of the work which I want to present here. How a particular material can support in varied applications. So here you can see that this is the pista shell, which is taken after consuming the pista seed. So this pista shell has been utilized in various cases as a composite, as a natural filler. This has been transformed into a carbon, and it can be used in the making of electrode in the case of battery, and it is going to be used as a biochar to improve the water retention fertility of the soil. It is used in gasifier to ignite, and it is used as an absorbent to remove the toxic violet dye, and is used as a ceramic to reduce the crack. See, one small shell, it is having multiple applications. So on these areas, if you investigate, you can able to bring out a good research. So this is the objective of just highlighting this particular work on pista cell. The first one is processing. See, you can see here in the slide, what are the various ways by which you can process it. So they are taking the shell, drying it, grinding it, making that as a powder, And after that powder, it is going to be blended with the matrix, maybe the polyester, and then blending it is going to be transformed into a composite. So then you can take up for further experiment. So this process we can very well do, and the rest of the process we can depend on some of the testing facilities available in and around industries and institutes. This is the another processing where you can see that the same pistol cell is transformed into a structural board. See the product. Previously, they are using only for testing, and later on, understanding that this is having good ability, they are using that as a structural board, which can be used for even construction purpose. And as I was mentioning, that the pistol shell can be used as a bio-activated carbon. So, what all the process they use here is they are heating, and after heating, it is going to be powdered, and they are using some alkaline treatment, and then it is formed as a slurry. Then it is going to be further heated in order to improvise the process of alkylation, and then transformed into an activated carbon. So this carbon can be used in the applications of making supercapacitors, right? And it can be used in the batteries as well. And the same shell powder is having a future scope that can be used in the making of water purifier as well. So this they have not touched upon, but we can use it in the place of a carbon filter. We can use this naturally derived carbon in the making of water filter. The same can also be used in the form of making a structural panel. So these two are still available as an opening for the research in terms of shell powder. And another way of processing is the same powder, we can able to grind it. Sorry. Sorry. Yes. So the same in the same way, we can able to do some sort of classification with the natural filler, and the natural filler can be blended with some of the polymer. Then it can be extruded in the form of a filament, and then you can use it for even 3D printing as well. So, but the problem is this: we can do it with the our lab, or whatever the lab we have in the engineering department. And for this extrusion purpose, we have to depend on some of the people those are having this extruder. So only this is the challenge. So once you can able to extrude that filament, you can very well use that for a 3D printing. So now we are blending our material with the advanced technology, wherein we can able to make some complex products as well. So this is how we should escalate our research. So here you can see another application of this natural fillers or fibers. So here there is a process called torrefication. Torrefication is the process wherein we heat it in the absence of atmosphere. That is, I can say that at a controlled atmosphere. So you get a torrefied mass. This torrefied mass can be treated as a torrefied structure, and then it can be blended with the polymer in order to make it as a composite. So this is how we can able to make the material transfer from one state to the other state. So what is the advantage of this torrification? Once you do this torrification, you can see that the properties of the material is getting enhanced. So here the mass which is not subjected to any process. Once it is torrified at a different temperature, so you can see that the compaction of the mass is taking place. So here you can see a lot of spacing, but here the spacing is decreased, and whereas here it is going to be in compact. So as you are increasing the compaction of it, you can able to see that the tensile strength is further increasing. So this is the advantage of this process. This process we can very well do even with the help of one small microwave oven. So if at all we have a microwave oven, but only thing is the atmosphere we have to maintain there. So what we can do is we can have a vacuum pump, we can evacuate that, and you can create a inert atmosphere, or we can have an atmosphere where the oxygen content is very less, and we can be able to do this torrification process. So these are all some of the work which has been done in response to support the sustainability and increase the utility of the natural fiber composite. And these are all the current research scopes which you can think of. Bioplastics are derived from renewable sources such as polysaccharides, fats, oils, and proteins and microbial polyester. So these exhibit biodegradability and it can safeguard the environment. But only thing is we need to know how these extractions are done. For that we need the support of industrial chemistry department. So in such cases we can able to have a collaborative research as well. And what are the challenges we have? So major biopolymer which are all used in our day-to-day life having a lot of challenges. So before going into the challenges, we can see into it how and all we can able to address that. So here one of the method what we can do is we can able to coat that, or we can blend it with some of the nanoparticles. So here you can see that these are all some of the nanoparticles: copper, gold, silver, zinc oxide, graphene, carbon nanotubes, and titanium oxide. So once you are adding these nanoparticles along with the biofiller, so that will enhance the properties in various dimensions. So some of the things may be very costly, like carbon nanotubes and all, but zinc oxide nanoplates and all we can able to try off that. So that will enhance the tensile strength, the biodegradability nature, antibacterial activity, waterproofing, thermal stability. So based on the application, more often we work on structural applications. So in that case, how we can able to blend all this and we can improvise this properties of the natural composite. And this is one of the work which is taken from the literature. Chitosan nanomaterial which has been blended with zinc. So you can see that how the load carrying capacity is increasing. So the load carrying capacity is tremendously increased, starting from 0, that is without any cellulose, that is without any zinc oxide material. It is having a very lower stress of around 50, that is the ultimate. But once you are adding, it is going up to say 75. So another one is with the starch addition, chitosan nanoparticle based on bioplastics. You can see that the percentage, as the percentage is increasing, of the starch percentage is increasing, the elongation to break and the Young's modulus is also increasing. So these are all small work which we can able to try with the available resources. And as I mentioned, this blending. So you are having natural fibers, you are having polymers, and we have to incorporate some of the nanoparticles like nanoclays and nanosheets. So by which we can have an overall enhancement in the properties. And coming back to how and what we can do. So we can think about this various combination of this reinforcement fillers with the biopolymers and various methods. So these three are the factors. The first factor is the fillers or the reinforcement. The second factor is the matrix. And the third factor is the manufacturing process. Say, for example, if you are taking a combination of a CNT, PLA, and you are using as a solution casting method, we may not get a good result. So that can be obtained or achieved in terms of melt extrusion. So the process is one of the factor, the polymer is one of the factor, and reinforcement filler is one of the factor. So you can take to any two or any three combination of the factors and you can study about how the properties are varying. So thereby you can optimize the process parameters. So like that you can able to take up your research further. And this is one of the application which recently people have deployed using a bioplastic with the silver nanoparticles. So bioplastic we know, which is bio-friendly. Sometimes it is biodegradable based on the resources and the category. And when it is mixed with the silver nanoparticles, it is improving the mechanical properties. It is improving the antimicrobial properties. It is acting as a barrier for water permeability, air permeability. It is increasing thermal properties and water resistant properties. So these are all the various avenues of research by adding only silver nanoparticles with the bioplastics. And that has been used for packaging various types of foods. You can say vegetables, meat, and some of the bakeries. So this is the type of research what in European countries people are doing in order to safeguard both the environment as well as to support the society. And this is another work where PLA is blended with PBAT. So here you can see that when you are using a normal PLA and PBAT, you can see that the growth of mushrooms, that is the growth of bacterial growth, is seen here, right? When it is packed with PBAT with 2% of trans cinnamonalide, so it is nothing but our cinnamon powder, and on adding that we can improvise the quality of the bread. So even after 21 days, the quality of the bread is good. So coming back to the key challenges. So use of nano-enhanced bioplastics, we need to have a regulatory framework. So once you are using that, we cannot simply deploy that, how it is going to be useful to the society. We have to form a regulatory framework. So this is very essential. So this can be done by a robust research. And we have to develop some of the standards like ISO, OCED standards, which will comply upon whether it is going to be user-friendly, free of toxicity, and it can be having any potential support to the environment. So these regulatory approaches will address public concern when any risks are there that we can able to suppress. So polymer and fiber degradation, higher moisture content, flammability, and poor bonding. So we can start when you are doing the research. Our research should be a bottom-up approach. So initially we cannot go for the regulatory framework. What we can do is we can able to develop a solution. We can study the response of the material, and we can see with that whether it is going to support the environment and the intended application. Then we can go for getting some standards, and then we can submit that as a regulatory framework. But when it is going to be application, when you are going to see the application, people will first look into whether it is following under a regulatory framework. So always the research will start from bottom and it will go up to the top in order to formulate a framework. And as I mentioned, we can have a lot of manufacturing process. Say starting from our hand layup method till 3D printing, we can explore each and every process. In some of the process, some of the ingredient, some of the making method will enhance the physical properties, mechanical properties. So in such circumstances, your product, your innovation may be much better than the previous one. And what are all the treatments? This is the basic challenge that we all have to start whenever we are initiating from the newer material. Like as I was mentioning about the need of FTIR in order to get the functional bands, chemical bands, and XRD in order to know about the what you call the crystalline nature. Then we can do some sort of hybridization. This is also much more coming up, as I was telling about usage of fillers, and we can bring in additive manufacturing. So making a filament, and we can even study the need of the friction and wear test. So these are all the various avenues where we can collaborate in order to make up new research. And coming back to the overall conclusion, so as the globe is going towards green chemistry principles, so green chemistry principle indicates that we have to make a product. That product should not create any damage to the society. So that should be energy efficient and less chemical synthesis. And at the same time, the product, whatever we have, that should be having properties of higher strength, higher life, and it should be recyclable in nature. If it is not recyclable in nature, if you are going to dump it, it should not harm the environment. So that is possible only by selecting what type of resources. So our research is going to have space in all the three domains. What type of ingredient you are going to select and how it is going to be processed. And the processing is going to enhance the durability of the material, whether it is going to be recyclable or it is going to be environmental friendly. So in a single nutshell, we can say that the research is wide open in all the domains of the material synthesis, then testing, as well as whether it is going to be recycled or not. So with this a small overview of about a biodegradable biocomposite, I expect the people of this forum to encourage the students of your group or your scholars to work on this type of material, which is going to be fruitful in future as well. If you have any questions, you can ask, please.
Participants, you are free to unmute yourself. Hello, sir.
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 Yes, sir.
Regarding postdoctoral journey, sir, can you share your transformation from private engineering college in Chennai to Central University, sir?
So what you are asking? Can you repeat, please?
Sir, much of the people here does not know about your central. You are working in a Central University right now, sir.
Yes. Sir.
That transformation, what measures you have taken from 2020 to 2025, sir? If you can describe, it will be helpful for many scholars to take up as an inspiration.
Yeah. So actually, I was in Chennai only. That is, I was working with the RMK group of institution for a very long time of around, I think it is around 19 to 20 years. And then I got an opportunity to go abroad to United Kingdom, where I was working in a composite research center. So it's all started from my PhD research career. So there I worked on fatigue studies of composite material, and I did some work on that fatigue studies, and based on that I applied across the globe. And I got a call from University of Wolverhampton, which is in UK, close to Birmingham. There's a place called Birmingham. I was working there for 1 year. I was there as a postdoctoral research associate. And there we used to develop and study the behavior of composites for high-end applications like high-speed cars. They're all very good in motorsport, actually, like our Formula 1. So we were doing some sort of testing over there, mostly on fatigue test. So where I got an opportunity to work with different companies, because it is the project wherein we have to focus more on industry-oriented work. So we used to get a lot of calls from various industries like battery manufacturing industries, automobile industries, then aircraft industries. So our objective is to find out what suitable combination of material manufacturing process, and then we have to do some characterization testing, and then we have to deploy that for actual application. This was the study. and we completed near about four projects, and 2 projects were about to complete. So in that state, my tenure got over because it was a short-term visit to UP, and I came back to RMK. Then I was searching for some professional growth in my career. So I was applying to various universities. I applied even to NITs and IITs. And I got a call from this particular university one fine day. Then I came here for interview. And it's just about our academics and research only they asked. So there were some few panel members. Luckily, I got one panel member from Anna University. So he was the person who was recognizing my work, and based on that, he was asking some question. Though we were not connected before, and once he saw my resume and saw my work, I did some work with our Anna University professor as well as IIT professors. So there, some or other, he got impressed with my work, and it was a very big interview. And I did my work, and later I got a call from that you have been selected for this post. If you are willing, you can come and join. So this was the background of the journey. Nothing special I did. Only thing is some good quantum of research and application-oriented research. That is very important. So whatever you do, at the end, where you are going to apply. So I think that is the point where it got me some good credentials over here. So other than that, nothing special. I also did my studies only from South only. So only thing is the research which I did during my PhD and in my postdoc, that helped me to find a better place. That is the only difference I think which made with other candidates. Other than that, all are same.
Well, sir.
Any questions from people?
I've been also traveling for about 5 years with you. I've seen your commitment and determination in research towards the composite material, particularly its natural fiber composites. Not only your faculty members in RMK, any of the faculty members in and around Chennai who are working in the field as a research scholar recognize your work and they refer your work. So that's a real inspiration, because we wanted to select you based upon your domain only. Because the sustainability factors would not have met if we are not keeping on using this kind of biodegradable materials and going towards zero waste. And you have taken it as a goal towards making many more projects through student projects. So your determination is very great profile.
So basically, our students are our strength, sir. Actually, I consider that as a very important strength of each and every teacher. So we don't know from where we get a result, but each and every student will contribute. So only thing is how we are going to travel with the students and how we give them work. So each and every one in our place, especially in South, the students are our strength actually. So they work to satisfy some of the basic requirement, but in that basic requirement, we have to bring in some research-oriented work. So that is how we did some of the work. So all those patent and all, we gave the idea, and student they involved themselves and they try to extract. Only thing is we should have a regular follow-up and regular support. So monetarily we can support, but the physical work, because most of us will be engaged in departmental work, institution work, accreditation work. So in such situation, we need support from the students. So students are our real strength. So some of the students, they really helped us, and it is going to be a mutual benefit. So they also take the credit of this patent as well. So our intelligence and their physical support and hard work and getting the things done, that only made us to make up some of good articles and some good work.
Very inspirational words. I think faculty members gathered over here will also follow your footsteps. Any other technical doubts people have? Usually they post it in the chat box.
Okay, sir. Okay, sir.
Faculty members from the other.
I could not see any questions in the chat box.
Sorry, sir.
I could not see any chat box questions here.
Yes, sir. Today is not posted.
Okay.
Okay. Okay. Sir, one more question from my end on behalf of faculty members.
Sure, sir.
This collaboration between students and faculty is there, like other than patent, other than publications, in social relevant manner, is there any possibilities to orient students so that they get into entrepreneurship or any other thing? Is there any ideas, sir?
Sir, can you make it a bit louder, sir? Your voice is breaking.
Not only the patents, publications, students are also involved in some kind of social relevant activities nowadays. So they get into entrepreneurship. Much of the people, they do some work, but they don't know exactly how to do it. So can we direct towards these goals of sustainability so that they thrive in the market? Also, they get very useful for the society.
Sir, actually, this sustainability, sir, now we are in the growing stage. In our country, we are in the growing stage. So two major areas people are working is this renewable energy and biodegradable material. So these are all the two areas which people are majorly focusing nowadays: renewable energy and biodegradable material. And other than that, all are going to be in the form of a conventional material and conventional product only. So for this biodegradable material, people have to visit some of the institutes which are all working on this area. And for renewable energy, recently the ministry has called for some sort of conference, some conclave they have conducted in Delhi. So I don't know whether the students will be permitted to visit there. So teachers, we can register through our institute, and we can go and get to know what are all happening and what is the interest of the government and what is the interest of the industry. So those information we can acquire and we can bring it down to the students' knowledge. So that is possible. So that is one of the way we can able to get to know what is the support from the ministry and what are all the avenues that industry is going to give us, and what is the objective of the government as well. Recently, I came across that our Prime Minister has announced somewhere around 2 lakh crore, which is going to be allocated for this sustainable growth. It can be in energy, it can be in manufacturing, it can be in material, it can be in biomedical. So it is going to be a very wide conclave which has been recently conducted in the last month, I think. So these type of conclave is the real platform where people from all over research institutes, starting from CSIR, all CSIR lab, DRDO lab, NAL lab, HAL. So all these areas, people were coming and they are presenting their need, requirement, and the objectives of their industry for up to 2040. Up to 2040, what is their objective? So like that, some of the forums are happening. So if we can visit those forums, we can get to know where we are and what is the expectation and what sort of support we are going to get from the government of our country. So this is one of the biggest area we can look in. And another avenue is we should have some collaboration with some research institutes like CSIR labs. And basically the problem is to go and meet with them, we should have some contact. So other than that, they won't entertain us. So that is the way we can able to get to know what is the requirement. And as a whole, the requirement is so huge that we cannot achieve as a single person. So what we can do is from that we can divide them at small modules, and those modules we can give it to our students. In a batch of, say, class of 60 are there. If one or two presentations, if you give, some of the students may get some sort of interest in that work, and they will come up. So this is how we should progress, because institute other than IITs and NITs, we don't have a strong research culture. So that is another drawback what we can think about. So keeping the drawback aside, if you want our students to progress and as we want to progress, so these types of information we can break down and we can bring down that as a small module which our students can do, a group of students can do. So that we can deploy and we can make them work. And that work we can club together and we can make as a small publication, something like that.
Super, sir. Super, sir.
And another important thing is whosoever we are having in a group, we can collaborate. So the collaboration among the faculty is also very much essential. In day out, we do our regular academic work and we move out of the campus. But at the end of the day, when we are submitting our appraisal, we don't have any research component. So we can have a collaboration in a healthy way. Healthy way in the sense how I am going to contribute for your upgradation of the research and how you can contribute for my research upgradation. So like that we can form a small group of a team of members, and we can able to contribute one among the team, and we can able to progress our research. So this also we can think of.
Thank you, sir. Thank you for your advice, sir.
Sir, it's not advice. It is my because all are having their own intelligence to do. So this is my way of how we can able to do, because we are all as a separate person, we cannot achieve things. But when you work as a team, we can able to progress faster.
Very well said, sir. So it's time for concluding the session, sir. Formally, thank you for committing to the program, committing your time instead of working day, and joining on time and giving all possible your research interests as well as your thoughts towards students as well as fellow faculty members for collaborating. So we would like to have in the other session also, probably in the personal meetings also. If you come in person, you can visit our campus for a personal invite to us. So if there is no question, sir, we can. People are asking for the PPT to be shared in the forum.
Yeah, I'll send you the PPT, sir, to you, and you can share it to the people, sir.
Okay, sir. Okay, sir. I will send you a feedback form also, how the program was. Thank you very much for
So thank you very much. I should be thankful to you and to I forgot his name. 1 minute, sir.
The coordinator name is Dr. M. Salam, sir. And along with me, Dr. R. Ganapati Srinivasan has coordinated this program for the past 5 days.
Sir, can I have Shankaralingam? Shankaralingam was my old colleague. He was with us in the RMK group. We worked together.
Issue can't able to conduct, sir.
Sir, how are you, sir?
So fine, sir. Fine, sir.
Okay. So I'll share you the PPT to Muthukumar sir mail ID, and you can send it to the participants.
Thank you, sir.
So thank you very much, sir, Muthukumar sir, for your invitation and organizing this FDP. Okay. So as we are talking, we'll also collaborate to do good research, sir.
Sure, sir.
Thank you, sir. Thank you, sir.
Bye, sir. Bye, sir.
The speaker may leave. Please be in this session, please. Thank you, sir.